So, friends, welcome to this lecture series of geomorphology and especially the soil classification. So, if you remember, we are talking something about the soil formation and its significance on the earth surface. How soils are being used to define the paleoclimatic changes, the tectonism, the paleogeographic changes, etc. And now we are going to discuss elaborately what is soil classification and why it is useful. Whenever we talk about this classification, that means we are categorizing something. So, categorize means we are making it easy to understand. Similarly, the soil classification is also one process where we categorize the soil into different categories and different categories of soil that define a particular type of geological environment, particular type of climatic conditions, paleogeography, that where the soils were formed. Similarly, the paleo soils, if I understand, these paleo soils are those soils which are formed in geological past and later the soil formation process was cut off from this main atmospheric system and they were buried under new sediments. Similarly, the classification of paleo soils also indicates what type of geographic condition, what type of climatic change, what type of tectonic scenario, what type of parent material on which they were formed. So, today we will discuss elaborately what is soil classification. So, soil classification is an attempt to classify according to definable, observable, chemical and physical properties of horizons of soil profile. So, if you remember last class, we are talking something about soil profile and finally, we concluded there are 5 principal profiles and out of which the B horizon of the soil is plays a major role to defining the soil classifications. So, B horizon, it is the degree, it is the horizon, it is the layer of accumulation of elements. So, in B horizon the soil structures, the beds they are formed and those B horizons they indicate what type of chemical changes, what type of physical changes, what was the topography, what was the timing and how the groundwater movement was there. So, all these things they can be derived from this information of the B horizon. So, now it is a definable and observable chemical physical properties. That means, once we classify the soil, we define and observe the physical and chemical properties of the soil. Physical chemical properties means it is alkalinity, acidity, the degree of soil development, whether this and the structure of soils like soil beds, like it is either it is granular or it is massive or it is prismatic like that. So, in this way what suppose we say it is a prismatic soil, it is a chemically or it is an acidic prismatic soil. So, what does it mean? So, acidic means it is an environment, it is saying it is an environment which is acidic condition, that means pH less than 7. So, that means there was no circulation of water, no exchange of chemical elements from this basin or from the region to other side. So, it is a acidic environment and prismatic means that means block type, either it is angular or subangular, that is different issue, but it is prismatic once we say that means a prism type, block type. So, block type means it says that means no sufficient pressure was there or no sufficient overloading was there, that means it is a free space. So, that means it is a horizon which was exposed to the surface, later on it was not compressed. Similarly, if we say it is a platy means it is a plate type, it is a compressed type. So, that means I want to say by looking a soil bed, by looking its chemical properties, by analyzing its characteristics, we can say what type of physical, and chemical environment was prevailing during that time. So, what does it mean? It means it is indicating the paleoclimatic condition, it is paleodepositional system, it is paleotectonic scenario. All those those parameters can be derived from the soil properties itself. So, this soil classification, it was proposed by US Department of Agriculture in 1965, and this is the best classification so far available. Though there are some classification schemes has been proposed by different countries of the world, but this classification by US Agriculture Department in 1965, it worldwide being used comprehensively to classify the soil of different regions. So, it is soils forming processes yet to be devised and it is being used worldwide. So, this US Department of Soil Survey, the classification, it was or it is being used worldwide. Now, you see, if we classify the soil structures here or the soil textures here, percentage of clay, that means this is boundary, this corner it is defining the clay, and this is percentage of silt and this is percentage of sand. So, based on this 3 sand, silt, clay, we define the soil textures. Why not boulders? Because we know the soil, once we say it is the sufficiently weathered and sufficiently changed its properties. That means, its earlier characteristics, earlier parent rock characteristics has sufficiently been changed. That is why it is called soil. That means, the rocks earlier the parent rock has been physically weathered, chemically altered, biologically transformed, then a total system is called soil. So, once we say physically altered or physically disintegrated, that means the parent rock has been disintegrated into minute particles. Chemically altered, that means it is exchanged the minerals, it is exchanged the ions. Biologically altered, that means it is added the biological material with it. So, now if we analyze this total system, it is composed of small particles, that means starting from sand, then silt, then clay particle. Apart from that, we have some organic matter. So, that is why once we go for soil classification, we must confine ourselves in these 3 size classes like sand, silt and clay, and if it is organic matter is there, that will adopt a separate classification taking organic matter as an constituents. But here it is a textural classification we are saying. Textural classification means it is the texture, it is the relationship of one grain to another grain. So, in this case, as we know, the soil is composed of fine grained particle, that means starting from sand, silt and clay. That is why the sand, silt and clay are taken at 3 end members to classify the soil texture. For example, if you see here, we have clay, we have sand, we have silt, 3 end members. This part it is sandy clay. Similarly, silty clay, silt loam and loamy sand, silt. So, these are the terminology we used for texturally classify the soil. So, that means, suppose we say in soil classification there is a parameter, what is parent material. So, once we say parent material, that means from which the soil is developed, that is the R horizon. So, if the R horizon or C horizon we are talking, C horizon is the parent material, that is alluvium, and R horizon is the bedrock. So, here the alluvium once we consider the C horizon, not the R horizon. So, here in C horizon we will get clay, here in C horizon we will get silt, C horizon we are getting sand. So, if in mixture of certain percentage, either it is sandy clay loam or it is loam means here clay percentage, sand percentage and silt percentage varies from this. So, this is called loam. So, loam is the parent material, or clay is the parent material, or sand or silt is the parent material. So, from this parent material, this has been sufficiently weathered, it is agglomerated with this organic matter and forming a soil. Under this scheme of soil health card, under the scheme of soil health cards are provided to all farmers so as to enable the farmers to apply appropriate recommended doses of nutrients for crop production and improving the soil health and fertility. It is very important to understand here why we classify the soil, because until unless we know on which class our soil is, it will be very difficult to recommend what type of crop we are going to grow on it. So, this is the faulty way of cultivation that still now we do not have an idea in our country or in global scenario if I talk. So, we do not have an idea how our soil is competent to a particular kind of crops. So, that is why we need a classification. So, in classification generally what we say in modern classifications, we classify the soils in terms of nutrient availability. So, in a particular soil developed in a particular environment or particular climatic condition and a particular parent material, so it will contain a particular type of minerals, and those minerals may suitable for a particular type of crop or may not suitable to a different kind of crop. So, that is why once we analyze the soil in terms of chemicals, in terms of chemistry, in terms of mineral content, nutrient content, that means we can categorize, yes, this soil falls in this category and it is suitable for these crops, and this soil forms under this category and it is not suitable for this crop. So, that is why soil health, if we do not know, that means without knowing the soil health, if we are going to cultivate, we do not know whether this particular soil will adopt this type of farming or not. Similarly, the soil health, it changes from its beginning to now. These changes are two types, one is the natural changes, one is the artificial changes. For example, suppose in a particular area, a particular crop is being cultivated for hundreds of years. So, that means a particular type of nutrients is being continuously consumed by this crop. So, that is other residual or the residue or the residual minerals or the residual elements, they are getting enriched in the soil. So, that means initial soil, if you compare, it is consisting of a particular type of minerals or elements. Nowadays, this it is different scenario, that means a particular element it is totally consumed and this remaining soil is enriched in other type of minerals. So, that means soil health is being changed. Similarly, in natural process also this soil health is getting changed. How? Suppose a particular type of soil which is very close to a river flood basins or flood plains. So, every year there will be flooding, there will be siltation, there will be sedimentation and there will be water percolation through the soils. So, in this way an element is being added and particular elements are removed. So, that means once during the formation of a soil for a particular parent material, this elements was X, Y, Z, P, Q, R, S suppose, but nowadays due to continuously flooding, minerals constituents are being added to it, some minerals are being removed from it by percolation, by water soluble minerals are going out. So, that means soil health is also getting changed. So, that means soil health is a function of different kind of parameters like this some of these parameters they are natural occurring and some of these parameters they are artificially being thrust upon it. So, that is why knowing the soil parameters, knowing the soil health, it is very important to address the present scenario of cultivation of the subcontinent. So, US soil taxonomy or soil survey staff 1975, the hierarchy of term in descending order of soil rank is, one is order, suborder, grade group, subgroup, family, series. So, these are the classification, that means like our stratigraphic classification, eon, era, period, like this. Similarly, soil classification, the descending order of rank, that means first is order, that means it is a larger rank, it is a broad, it is order. Then again order is subdivided into suborder, suborder is subdivided to grade group, then again divided into subgroup, then family, then series. So, these are the hierarchy of classification. 11 soil orders are defined. So, once we have 11 soil order, so that means soils, the whole world has been classified or has been categorized into 11 orders, 11 broad groups based on the presence or degree of development of their various horizon of the soil profile. That is important to know. These 11 orders has been defined based on the presence or degree of development of various horizons in the soil profile. Degree of development, if you remember, we can say the degree of development means how definedly, how precisely the soil structures has been developed, the pads has been developed. That means, if a soil horizon, and whenever we talk about the degree of development of soil, we are talking about the B horizons. So, that means the B horizon, how well it is developed, whether these pads has been completely developed and plates have been matured, or this pad has been compressed, the pads are prismatic in nature, or the clay coutons are there, thick clay coutons are there, thin coutons are there, mottles are there. So, in these basis, so that means this is the scenario, this is the complete package for defining a degree of development. So, based on this degree of development, various soil horizons, the soil profiles has been, or the soils on the world has been classified into 11 orders, that means broad 11 subdivisions. The name of each soil order ends with sol. Sol, it is a Latin word and its means, Latin word is representing solum and its meaning is soil. So, every 11 order, the end is sol, like this, suppose for example, it is antisol, vertisol, molisol. So, that means the sol is, that is the name of these orders, and the sol is the representation of soil and contains a formative element that is used at final syllable in the name of taxa, suborder, grade group, subgroup. So, the prefix is something else. The prefix with soil, sol, it is used to name a soil order. The prefix is the names of taxa, suborder, grade groups and subgroup. That means, if we break those prefix, if we analyze the words in the prefix, you will find the soil characteristics, that is which environment it was, which type of parent material on which it was formed. So, all those things, they are restricted, they are capsulized within the, that is the prefix used with the sol. So, now here these 11 orders are listed. One is alphisol, andisol, aridisol, antisol, histosol, like so on. So, here if you see the sol, with the sol the alphi is associated, the alphi is the prefix. So, by analyzing the meaning of alphi, why alphi stands for, we can say what type of environment, what is the color and what is this parent material, what type of geochemical condition in which the soil was formed. So, all those informations, they are compressed together and encapsulated within this term alphi. For example, here if we analyze the alphisol, we can say soil with grey to brown surface horizons, medium to high base supply and a subsurface horizon of clay accumulation, formative element is alp. So, alphisol, alp sol, alphisol. So, this ALF, L F for stands for aluminum, F for ferrous content. So, all those elements, this informations behind the names, it indicating what type of characteristics of soil is there, what type of environment on which the soil was formed, and why this ALF it is standing, why it is there, and what type of geochemical environment which was responsible for accumulation of aluminum, for accumulation of iron in the soil horizon, that can be unravelled by looking the soil name. So, here the formative elements are derived from Greek or Latin roots, are as short as possible, and are designed for use in any modern language. So, here the alph is the formative element, here and is the formative element, here ENT is the ant is the formative element. So, those formative elements, they are of Greek origin or Latin origin. So, these are the short form of a particular terminology, and those short forms, they are encapsulated and they are encapsulating some information. By elaborating it, we can get what type of parent material is responsible, what type of climate was responsible, what type of base exchange reaction was responsible. So, what type of environment was responsible for formation of the soil. So, if you analyze all those names, it is ending with sol. Sol stands for soil, and those formative elements which are used as prefix, this part which are used as prefix, those indicate what type of environment, what type of chemical composition, what type of tectonic scenario, what type of base exchange reaction, what type of parent materials they under which or from which the soil was formed. So, now by compounding the several ranks of formative elements, any soil type on earth can be classified. For example, if you see here anti-soil, here soils not dominated by swelling clays. Again, it is soils with no V horizon. So, ENT, recent, it stands for recent, RECENT, this ENT it is for recent. So, if we remember your last class, when we were talking something about the time or this chronostratigraphy of soil, we are talking something that with time the thickness of the soil horizon increases if other parameters remain constant. So, in recent soils which are recent, very recent, that means there will be no V horizon, because V horizon formation takes time. It is from elevation of material and accumulation, and it is the reaction from the surrounding material, binding of the surrounding material. So, by which the B horizon will be formed. So, formation of B horizon will take some geological time, and recent soil which is sediments deposited very recently is hardly the B horizon is developed there. So, that is why recent soils with no B horizon, and soil not dominated by swelling clays. Why? Once B horizon is not developed, that means this sediments or the rock has not gone sufficiently weathered. It is the soil deposited or formed on the alluvium. So, to weather to that degree of minerals to form the swelling clays, it also takes time. So, that is why recent soil or anti-soil, it is neither the B horizon is developed nor they contains swelling clays, because swelling clay formation it also takes some geological time from weathering of silicate minerals. So, that is why if we analyze the anti-soil, that means we are saying ENT, recent. So, recent soil or anti-soil, it does not contain V horizon and does not contain this swelling clays in the soil body. Here vertisol, soils dominated by swelling clays, soils dominated by swelling clays. Swelling clays means again the clay is formed from the weathering of the silicate minerals, that means it has taken time. Okay. So, that is vertisol. Here soil with little profile development, this side soil with moderate profile development, soil with highly weathered and soil with volcanic ejecta. So, now if you see here in I compare these two, soil with little B horizon development, that means the degree of development is less. Here with moderate B horizon development, that means soil which is developed relatively more as compared to the upper part. So, the degree of development as it increases, the soil properties changes, the mineralogy changes, the exchange reaction changes, the pads, the development of pads changes. So, that is why some changes also occur within that mineralogy, within the soil horizon, the thickness changes, the color changes, the mineralogy changes, is not it. So, now soils with weak B horizon, that is incepty soil. Soils with mostly weak B horizon, that is soil usually dry, arid soil. Arid soil, arid, it stands for arid region. Arid region, if you go there, so that region is dominated by physical weathering. Arid region is mostly dominated by physical weathering. So, physical weathering, it is responsible for breaking down of minerals from larger to smaller particles. But for B horizon, for development of B horizon, only breaking down of mineral is not sufficient. The chemical breakdown is important, because clay minerals has to be developed. In that case, that is why soil with usually dry region, in arid region, that is called arid soil. Soils with mostly strong B horizon, soils usually moist and thick black A horizon, that is molly soil. Soils with mostly strong B horizon, strong B horizons means more chemical reactions, more chemically breakdown of rocks. So, that is why usually moist, which moist, because if you remember last class when we are talking something about the water, the moisture, role of moisture in soil horizons, then we find the warm humid environment is more responsible for breaking down of minerals for chemical weathering, and more chemical weathering, that means more thick the soil horizon is. So, that is why if you analyze here soils with mostly strong B horizon, that means here soil usually moist, generally moist means it is promoting chemical reactions, chemical breaking down of mineral, development of clay. That is why it will develop a thick B horizon as compared to other part. Soils with clay enriched B horizon, soils with thin A horizon over E horizon, and that is alphisol and altisol. It is fertile C, infertile C, that is altisol and it is alphisol. Soils with clay enriched B horizon, that means more accumulation. More accumulation means more leaching, more accumulation in B horizon, that means more leaching in A and E horizon. So, that is why here usually thin A horizon over E horizon, that means totally leached soil, that means the A horizon and E horizon has been leached down. So, that is why here that will be thin. Then soils with iron and OM enriched B horizon, organic matter enriched B horizon, that is called spodosol. Here iron will be enriched, then organic matter will be enriched. So, that is called spodosol. Soils highly weathered, that is oxisol, that means oxygenated, oxidized, it is highly weathered. Soil developed on volcanic ejecta, like volcanic ash, the tephras. Soils with colloidal fraction dominated by allophans and similar minerals Al humus complex, that is called andisol. Similarly, organic soil greater than 25% organic matter, that is called histosol. So, these are the 11 orders of the soil, that is means that is the broad classification based on those properties. Based on these properties, the 11, these are the 11 soil orders that has been worldwide the soils has been classified. Now, we will go to suborders, then great groups, then subgroups, then family like this. So, after orders, the next lower hierarchy, it is the suborder. So, if you see the suborders, it is alb, aqua, arg, bore, flub, orch. So, these are the formative elements for the suborders. For example, alb, alb is a Latin word, it is stands for albus, that means white. So, soils form which clay and iron oxides have been removed. So, now if we remove the clays, we remove the iron oxides, we remove the iron stains. So, it will be totally light color soil. So, the alb stands for Latin word, it is albus, that means white. So, this white color in a soil, white color soil will form, that means iron will be removed, clay will be removed, then the remaining mineral will be rich in white color, minerals are there. Similarly, aqua, so stands for aqua, that means water. Soils that are wet for long period. So, most water, most soil means chemically reactive soils, thicker chemical horizon, thicker B horizon will be there. Arg for argillite, argillite means clay, soils with a horizon of clay accumulation, that is called arg. Similarly, bore, boris, northern, that is cool, that is a Greek word, boris means cool. So, those soil which develop in cold environment, this formative element is used for that. Flub, flub is river, soil formed in alluvium. So, soil which is formed in alluvium, this formative element, it is this flub is used. Similarly, these are the formative elements, they indicate different type of environment, different type of chemical constituents of these soils. Thus, the name of each of these 55 suborders consist of 2 syllables, a formative element. And if you see here, from north pole to equator we are moving, these type of formative elements, order, suborder, or this name of this soil profiles has been, name of the soils has been classified like here. For example, here is aridosol. Aridosol, if you remember few minutes back we are talking, it is indicating arid region. So, arid region, now you see here, arid region means salt accumulation. So, here soil, they consist of salt accumulation within that soil profile, like this calcrete development. Calcrete development, it is the indicator of arid region, indicator of arid climate. Similarly, we have salt accumulation here, that name is aridosol. Okay. Similarly, here organic matter, mollisol, mollisol means it is a organic rich soil. Here if you see here, increasing of organic matter, because here chemical weathering is more, here rainfall is more. So, that is why we are getting mollisols here, organic matter enriched. Now, principal formative elements to be used naming great groups. Next hierarchy, next lower hierarchy is the great group. Here cry, it is Greek word cryos, that is ice, this is cold soil, cold environment, it is indicating this formative element is cry. Destroy, dries, that indicates infertile. That similarly, these are these formative elements, they are indicator of great group. For example, if we a well drained soil formed in silty, calcareous, glaciolacustrine deposit of late Pleistocene age. Imagine a well drained soil formed in silty, calcareous, glaciolacustrine deposit of late Pleistocene age. So, that can be named or classified at the subgroup level as glossoboric hapludalp, glossoboric hapludalp. So, if we unravel this, if we expand these names, alp, it is the order alphisol, wood, ud, it is again suborder ud, suborder if you see here ud, that means it is humid climate. Then HAPL means here HAPL, HAPL, that is means simply at least advanced horizon, the least advanced horizon. So, that means I want to say, if we analyze this part of this soil, that means it will indicate what type of chemical constituents is there, what type of environment it was formed, and what is its degree of development, what is its organic content, what is the color of the soil, all those things can be unravelled by looking this part of the soil. So, now this term comes glossoboric, that means here decoding this, it is given here, decoded using the formative elements. It is belongs to a subgroup or get group of Hapludalph, the suborder Udalph, the order Alphisol, here Alphisol, Udalph, Hapludalph. Translating the formative elements of the name, the soil has a grey to brown surface horizon, because this we have to go for the meaning of this formative elements and the meanings from the Latin or Greek words. If we analyze those, so this is a soil have grey to brown soil horizon, moderate to highly base cation saturation and clay accumulation in a subsurface horizon. Formative element is Alph. It is the suborder of Alphisol. This Alph stands for this Alph, that forms in a humid region. Formative element is Ud, wood. So, these type of information can be unravelled, can be decoded by this name of this soil. Hapludalph, simply the latest advance of horizon. Ud, again Ud is humid climate. Then Alphisol, soil with grey color, surface horizon, medium to high base supply and subsurface horizon accumulation, formative element is Alph. So, that means I want to say, if we decode this second part, that means we can say different information, we can unravel different information regarding the soil development process, the environment, the parent material, degree of leaching, all those things. So, this is all about the soil classification. So, by classifying a soil, we categorize it as a particular category, particular class, and we know which class is suitable for which type of crops and which soil which is indicating the past geochemical environment, past tectonic scenario, past environment condition, etc. So, that means soil classification is an important parameter to define the past climatic condition and geological condition. So, that is for today. I think it is the soil classification is over. Thank you very much. We will meet in the next class. Thank you.